Hello, everyone.
So let's start.
Yes, I guess we can start.
Welcome to the Java in the AI Revolution 2024. My name is Vladimir Litvinov. I am Java team lead in the EPAM systems, and I will facilitate today's session. So, as you may see, could you please back to the previous slide? That we even have to change the name of the presentation because things in AI are changing too fast. So now we'll speak about the beginning of 2025. So let's move on. Today, our esteemed panel will shed the lights on the state of AI at the end of 2024, start of 2025. We'll speak about LLMs, frameworks, integration and architectural patterns, use cases, and also we will cover a role of Java in all of these developments. Today, we are fortunate to have an exceptional panel of experts with us today. Let me introduce them. Dmitry Hrustalев, software
Hello.
architect. He is here with us. Also, we have Danila Chechetov, senior software engineer.
Hello, Danila.
Artem Mashlenko, lead software engineer.
Hey.
Hello, everyone.
I also would like to highlight that we will have time and for discussions and for questions, so feel free to submit your questions in the chat. We'll answer them. So I believe without further ado, let's move on to the overview of AI landscape. Danila.
Before we start, let me also highlight several things about about this event that currently here we would like to create event like collaboration between our audience with the experts and audience and participants who currently participating in such kind of event. Feel free to ask any kind of questions. This is we will have some kind of discussion states where we will be able to discuss your questions, review. Also, we are going to provide you several tools and yes. And so
thank you, Dmitry.
Mm-hmm.
So, as I said, let's start from landscape of Java AI. Danila, the stage is yours.
So thank you, and let's start. Let's begin from the predicaments on the market. As we can see, Forbes made several predicaments, and from what they see, they say that the market size is expected to reach more than $400 billion by 2027. But as you can see, it starts in 2025. It's probably will be done during this year, especially with US investments of $500 billion into the AI market. Forbes also saying that I expected to see an annual growth rate by more than 30%. And on not so bright side and even dark side, they're also saying that expecting that 400 million workers could be displaced because of AI. And it only will create something about 100 million jobs. So 300 million people can be replaced and lose their bread and butter. But let's talk about why they are saying it and what are the field on which they are making these predictions. Starting from the number of AI patterns, we can see that number of AI patterns almost doubles every year. So more and more companies are creating something new and creating patterns for this. And it also can be seen even looking at GitHub. As we can see, the amount of projects which has some relation with AI goes and grows as rapid fire, and it reached almost 2 million at the end of 2023, and by the end of 2024, it was something about 3 million projects. And if we will continue to look deeper, we can see that private investments in generative AI sectors almost at the end of 2033 were $25 billion. And with modern investments from the United States, it will be even higher. So if you will compare 2022 and 2033, you will see that it grew 8 times. And if you will compare 23 and 24, at the end 24 when they made this investment pool, it will be even 20 times bigger. So, and it's not goes because everyone wants to spend money and be on the cutting edge of technology. They're doing it because they want to make money. And there are some surveys that's showing that organizations that I implemented AI into their products actually receiving money, as they're receiving positive feedback on it. As they're saying that 42 organizations report cost reduction and 59 report revenue increased. And the biggest affected fields were service operations, manufacturing, risk management, and human resource. And by reducing the cost, they also increasing their revenue. And it's other companies seeing that it's the other companies that implemented AI receive positive feedback, so they also want to invest into it, and it's created demand on the market. And to follow this demand, many universities are starting to create new possible programs for AI. And as you can see, it grows steadily every year. So more and more universities are ready to supply the market with new engineers, new professionals who know how to work with AI. And based on it, we can say that artificial intelligence is stock, and everyone should invest into it. And by saying invest, I don't mean invest money. That's probably also good. But most important, we should invest time to learn what it is and how to use it. Because our field is really exposed to AI, as we can see on this graphic, and it's already affecting the market. Such fields of work as JavaScript, interface design, cold calling, accountants, and others are falling from the cliff. And others such as IM interface, smart devices, and natural language programming are increasing popularity and growing. So in order to grow and to not follow from this cliff as JavaScript, we need to learn how to implement AI and how to use it to not be replaced. Because at the end of the day, AI won't take your job. It's somebody using AI that will take your job. Because, of course, AI can outperform human on several fields such as image classification, visual reasoning, English understanding. But when you're talking about complex tasks such as computation level mathematics, visual common sense, reasoning, planning, it actually struggles, and even not with you can check by yourself when you will ask some ChatGPT or any other model to ChatGPT, for example, or any other application to help you to calculate something. It will struggle. It can make easy calculation like plus 2 plus 2, but when we're talking about some complex mathematics, it actually struggles. So you need to remember that AI isn't some machine god that can do everything by itself. It's a tool, and you need to learn how to use this tool to become or stay relevant on the market and to not be replaced. So maybe we have some questions to discuss about this part.
Very much, Danila. So let's wrap it up with a couple of questions. Yes, so you highlighted that AI development is creating new jobs. But from the other hand, we have news that huge corporations like Meta and OpenAI is planning to replace middle-level engineers with AI solutions. So is it true, or is it just a marketing strategy? And maybe you can suggest some proactive steps for engineers to stay valuable in this changing world.
Okay, thank you for your question. Of course, it's possible to replace some middle engineer roles by AI, but it's impossible to replace everyone, and especially when we're talking about such big corporations as Meta, Facebook, and others, they often like to exaggerate to affect the market and to show that they're still on the edge, and they just want to make more money. But when we are talking about why it is possible or impossible, you need to remember that, as I told previously, AI can automate repetitive tasks, that it can generate something for you, it can work with well-described tasks. But when we are talking about actually working on the production, manage to do it. Because to do it, we need to be good and complex in complex problem solving, creativity, domain expertise, and we need to communicate with business analytics or with business itself. And I can do it, and it will actually struggle with it. And in order to stay competitive and to not be replaced, I will suggest to upskill your knowledge with data science or cloud technologies. I would also suggest focus on problem solvings and leadership. Because if you're talking about middle engineers, you can just continue to grow and hope that other engineers will be replaced and not you, because you will outgrow them. But it's just like a job, but not a job. And we also can learn other tools that we can integrate into our application, into our day-to-day job, to become more efficient and to be able to propose our own solutions to the customer or to the project, to become key person on the project or in the company. And I will say that it's the most important part of how to stay relevant and not be replaced.
Also, colleagues, as can you see, we pasted several polls. Please join the link and provide your answers. It will be very useful for us. And currently we have provided 2 links regarding the 2 questions. For example, provide the best example where usage of AI brought great benefits for the business. And another one, what is your favorite LLM model? At the same time, as can you see a question from the Pavel asking about current meeting, what AI means in scope of our meeting. And actually, Pavel, answer to your question is like currently in today's session, we are mostly focusing on AI and integration with our applications. We do not touch model creation, fine tuning, LLM ops, and all other kind of stuff, because this is kind of another area of discussion. But at the same time, we are going to talk again regarding the RAG system, agents, and multi-agents at the same time. Yeah.
I hope that was the answer to your question.
Yeah. We have a lot of questions, but we will try to answer them online. If it will be not possible, we will answer them after the meeting. Yes, please provide your questions as well. So let's continue.
Yeah. So we also mentioned Java in the name of today's presentation. So Danila, one more question to you. So is it real for Java engineers to do some transition into these more AI-focused positions without learning a Python?
Yeah, it's a good question, but in order to answer on it, we first need to understand what AI frameworks are already on the market, and especially look into the Python. We need to know what Python can offer to compare it with Java and to say whether or not we can continue to work with Java developers in AI world. So let's start from the Python. And here we can see 4 main frameworks of Python. And the biggest difference between Python frameworks and Java frameworks is Python frameworks, for most popular Python frameworks, they're highly specialized in their own field. For example, Llama Index, GUI, LangChain, and Out-Again. So let's discuss the benefits and disadvantages, starting from LangChain. LangChain is created for NLP-related tasks, and it excels there. It's really good for text generation, translation, summarization. It has a variety of pre-trained models, and you can use them right away in any NLP projects. It also has a user-friendly interface and big loyal base of clients that are always ready to support and have a huge variety of documentations and their own designed features or changes to help you with your projects. Out-Again was created by the Microsoft, and it was created to work inside the Microsoft ecosystem. It's not actually expected for you to use it anywhere else. It's really good with integrating with Microsoft features such as Azure AI, Azure databases, and everything. But outside of it, it struggles and can be compared to others. Llama Index was created to handle a wide range of data formats. and it excels on working with data. It makes it easy to compare various information sources. It has advanced indexing techniques to enable fast and accurate retrieval of relevant information, and it gives you a wide control and functional coverage. But last but not least is CrewEye. CrewEye is really good when you need to build and manage systems with multiple agents working together. It provides a great flexibility for customization and building your own unique multi-agent systems using machine learning models. And it also has, as a LangChain, a big community of developers who support and share resources between each other. But not everything is so bright, and of course, there are some disadvantages. In terms of LangChain, the biggest disadvantage is its highly specialized creation to work with NLP. So it's really good for NLP, but in terms of working with anything else in NLP, it's isn't so suitable, and beyond the NLP applications, it can struggle. And other,
Can I interrupt you here?
of course.
I wanted to ask a question regarding why we don't see on your slide something regarding semantic kernel, for example.
Yeah, of course. If you talk about semantic kernel, it's also a really popular framework, but it's not a framework that was created for Python or Java. This framework was especially made for C# and it sells there. And if you will compare the functionality of semantic kernel for Python, it's just a drop of things that it can do on C#. And we can compare the functionality of semantic kernel on Python and Java, it will be the same low level. And so it's isn't actually it's possible to use it, but it's not the best framework for the Python.
Okay, I got you. Thank you.
Yeah. And if you compare LangChain with Llama Index, when Llama Index is highly specialized for working with RAG and not with NLP, so it focuses only on data retrieval and it excels there. But for NLP-related tasks, it will be much better to use LangChain. And Aftergen is what I told you previously. It was created to work inside the Microsoft ecosystem, and outside of this ecosystem, it isn't the best framework to use. It needs to be used only inside the Microsoft ecosystem when we are working with Azure. And in other scenarios, it's better to use LangChain or CrewEye. And if you're talking about CrewEye, it's actually a great framework that gives you a huge possibilities of creating your own models and everything. But unfortunately, it requires a high level technical expertise to set up and to use compared to LangChain. Because LangChain has a lot of pre-built features, while CrewEye has a lack of them, and expected from you to make them by your own. And this is the biggest disadvantage of CrewEye. And looking into these advantages and disadvantages of each framework, we can make use cases for each one of them. LangChain for automated content creation, machine translation, text summarization. Autogen for everything that requires you to work with Microsoft. Llama Index is for Q&A chatbots, documentation, understanding, extraction. Autonomous agents that can perform research and take actions based on big data lakes of information. And in terms of CrewEye, it's use case when you need to create your own multi-agent system, created for different languages or different even scenarios in one agent that can handle it all. It helps with automated research assistance, fraud detection, and it has a good personalized learning platform. But now let's talk about how they work. We need to understand that it's not a magic, it's just API calls. All these frameworks, they have something like a field. They just using a lot of code and prompt engineering to help your API call to achieve that is want. For example, they're using such things as tools, as models to control it, tools to add some extra knowledge and extra functionality to your agent. But if you just look inside, it's just a lot of API calls that are going separately, sometimes even in parallel, to help you achieve what you want. And it's not some magic, and it's not something that is impossible to change. You can edge it by yourself, and it's not a big struggle when you don't have a pre-built features, because those features are usually just API calls with something extra, and you can build by yourself. And now let's talk about Java. Java, if you will compare Java and Python, the biggest difference is that Python most popular framework, they're highly specialized. And in terms of Java, our frameworks, they are mostly working with NLP tasks, and each framework just tries to take the biggest part of the market for itself. Here you can see the popularity of those frameworks, and it may look like that semantic kernel is actually really popular and is the best framework for Java, but it's not true. It's a main repository of semantic kernel that contains the solution for Python, C#, Java, and only like several months ago, they created a new repository called semantic kernel Java that contains solution only for Java. And as you can see on this graphic, this solution is really unpopular, and if we will look deeper into semantic kernel, we will see that it contains a really small amount of pre-built features, solutions, and it's not so easy to use, and it struggles to work. It not struggles to work inside Java. It can work, but it requires a lot of changes from your side and a lot of oversight from you if compared with Python or with Spring Guy or LangChain4j. And LangChain4j is like LangChain, but for Java. That can help us to understand why it has a lot of pre-built features, because they're mostly just converting features of the Python LangChain to the Java version. And as we can see, all of them have the same components: agents, chains, tools, memory. Those components can have different names, but on high-level abstraction, we can say that they're all the same and they're doing kind of the same way, the same things. For example, tools, plugins, functions, they all necessary to add custom components that can be used across different apps and can be called by application to help us do something. And if we will look into the implementation, we can see that the code of LangChain4j and Spring Guy kind of small. For Spring Guy, we are working with the same Spring framework. So Spring Guy builds on top of Spring framework, and because of it, we are working with it like inside Spring application. We need to add some bin, add some description, configuration, and we are ready to go. For LangChain, we need to add an annotation tool, and it will be possible by doing it to add a necessary tool. For semantic kernel, we need to define a kernel function, and unfortunately, when in Spring we just need to add several annotation for LangChain, we also need to add several annotation for semantic kernel. We need to define function, create function, and we need to set this function to our agent, and it won't grow by itself from annotations, unfortunately. And because of it, it looks like semantic kernel is actually easy to implement, but outside of just creating a tool or a function for semantic kernel, it actually requires a lot of other stuff to do on the background. And let's compare those frameworks by the most important part of our application, usually most important part, a data connection or data retrieval. We will compare LangChain Python with LangChain version for Java, semantic kernel Java, and Spring Guy. As we can already see, LangChain for Python overwhelmingly better. If we can even look on document loaders, we can see that LangChain for Python has over 100 different document loaders, while LangChain4j has 7. Spring Guy also has something about 7. And semantic kernel, as I was telling you as I was telling you already, isn't so good for Java and can work only with Word. And it's here just to make LangChain for GL and Spring AI look better. And we will talk about text embedding models that already have some integration with this framework. We can see that LangChain for Python has 25 different models, embedding providers, LangChain for G18, Spring AI 14, and semantic kernel only 3. The same story with vector stores. LangChain for Python has over 140 vector stores, and the LangChain for Java and Spring AI combined have something about 30 or 40. So we can see that in terms of tools, they have the same tools, but the amount of possible already made solutions for Java is much lower. So in big picture, we can do the same things as we can do with Python. But unfortunately, we need to do a lot more things manually by ourselves in order to connect with some vector stores, and we just generally have a lack of already made solutions. And this combined with the fact that Python shows us that Python already has a huge ecosystem of libraries and frameworks. Some of them are even specially made for some specific situations. And Python syntax is also much more readable and easier for rapid prototyping, which is crucial for current work with AI models, because currently we are just creating a lot of prototypes to show it to the customer. And this makes Python a default solution when we're talking about AI projects. But it isn't true, and it shouldn't be true, because even though it's better for prototyping, when we're talking about long-term solutions and production engineering, a lot of customers wants to have a solution that will work everywhere, everywhere and anywhere. Everywhere. Yeah, sorry. Wants to work everywhere. And in order to achieve it, they usually want to use Java, because Java works the same way. And it doesn't matter on which machine it runs. And it also doesn't matter that model can be written on Python, but we can just call it using Java API call, using some frameworks on Java, because as I told you previously, it's just API calls. So we can use the same API calls everywhere to achieve the same results. By working with Java, our old projects with old customers, that are still probably some of them using Java 8 or something like that, because there are projects like this, we can show customers that they don't need to invest more money into creating the same application on Python or integrating it with the Python. We can just say that give us some time and we will integrate AI into this application with Java. And they will be happy and ready to pay for us. So we can say that even though currently Python is the default solution, Java can also be used in many ways, and it's also a valid solution for many different projects, and it totally depends on what the customer wants and whether or not it's a solid application which plans to work for several years, or we are just creating a prototype and we need to make it in 1 or 2 weeks. I'm happy to hear your questions and your thoughts about this part of the presentation.
So thank you one more time. So I want to highlight that you mentioned Spring AI, and you were mostly talking about Java to AI integration frameworks. But I also want to ask, is there some solutions on Java that will help you to create, transform, train, and so on models? And is Java a good choice for such tasks?
Okay, let's start from the first part of your question. Yes, we have some frameworks like Deep Learning for Java or DGL, which support working with models and integrating AI into Java application. So we can say that we can use Java to create our own model and to teach it, but it's much more suitable to use Python for these cases, because Python has a big ecosystem of different frameworks, different solutions, and it's just the performance of these frameworks on Python are much better. And even though it's possible to do it in Java, I will suggest you to do it on Python. And Python still remains a better choice. But we still need to remember that, as I told you previously, model can be written at any language. But usually when we're talking at production, the model will be deployed somewhere on the cloud. It will communicate with it using API calls. And from this point of view, it doesn't matter which language we are using. So we still can work with Java.
Yes, thank you very much. So,
Yeah, thank
Dmitry, a small
Yeah.
question as to you.
Can I ask question also to Danila? Danila, what is your favorite Python AI framework, and what is your favorite Java AI framework?
For Java, I would say Spring AI, because for me it's easier to work inside the Spring, because I was working with it for many years and I just don't know how to work with it. And in terms of Python, for me, it depends on the task, because with Python, I have different projects with different needs. And if we're talking about NLP-related tasks, when we need to generate something to make something not so hard but valuable to the customer, I would prefer to work with LangChain, because it has a huge database, a huge support from different engineers who invest in time into putting the documentation into the LangChain database of solutions. So by doing it, I can easily find already made solutions or some suggestion on how to achieve the needed goal from these people.
Thank you. Also in the chat, we have a question from Konstantin regarding LLM implementation frameworks in Java. Konstantin, I guess you already got an answer from Danila. I hope it was detailed. In case of any additional questions, please feel free to ask. Yeah.
Okay, yeah, let's get back to my question. So Danila showed us such huge variety of those LLMs and AI solutions. So I want to ask you as architect to categorize them somehow to simplify the understanding, because it's too much information.
Yeah, actually, Danila provided us information about AI frameworks, right? And if we are talking about LLM models, I personally categorize them into the three big packages. First of all, it's LLM from big AI companies like OpenAI, Meta, Llama, Cloud, and for example, Mistral AI, this kind of big LLMs from big companies. And second package from my category list is open source LLM models, which we also love, which we can, I don't know, deploy on our own laptop or server and play with it. And last but not least, and very interesting, is small LLM models for specific use case, because they do not require a lot of resources. We know the task, we choose best small LLM model, and we use it in this specific scenario. In this case, my personal categorization is these three categories. And yeah.
Yeah, thank you for your answer.
Yeah. So let's continue with my part. I have around 10 minutes and I'll try to provide you a short overview regarding how we are able to integrate AI with our applications. Also, as I already mentioned in my presentation, we are going to talk about AI integration. We do not talk about patterns, how we can create LLM model, how we can fine tune them, how we can I don't know, how we can do some kind of LLM ops operation. All this information is scope of another topic, and currently I'm mostly focusing on AI integration with our applications. Yeah, Danila, let's go ahead. Yes, first of all, let's start with the simplest AI integration. I believe all of us started using AI using this simple integration when we have our own application, when we have LLM provider like OpenAI or other kind of provider, and using API which LLM provide us, we make a call, we create some kind of small prompt, we get response. And personally, I started my, I don't know, journey regarding LLM with such kind of implementation. But when I started, we didn't have Spring AI. We implemented request response by our own. We calculated tokens on our side. We made some kind of chunking and all other such kind of activities. It was interesting, but currently we already have libraries which can help us to do such kind of things. And after this first touch of AI, our clients started considering what kind of data they have. And we can move on. Yes, and start to talk about RAG, because client has own unique set of data, unique documents, and he would like to use this unique kind of data in scope of their responses to the users, because using this unique data, they will be able to provide more accurate response based on a question regarding the area which we are implementing AI, for example. And this is some kind of evolution of our applications, because we just started integration with AI. Now we know that we have some kind of data, and most interesting part in this pattern is to create this kind of data pipeline application. Because usually in this kind of application, we use another LLM model like text to embeddings, and use the data which we have and transfer them to the vector database. And this kind of also, it will be, usually it's some kind of separate service in our infrastructure, and we move this data to the vector database. And on another hand, we have our, for example, main application, which can contact our vector database and receive some kind of relevant document. And based on this information and based on enhanced context, we are able to make API call to the LLM and get very enhanced response. And yes, next is AI agent implementation, or like maybe you already know, React and ACT pattern. Actually, it's I believe also must be familiar, because on this slide, as can you see, I have provided information about AI framework, AI frameworks which we currently discussed. And what we have in this on this slide, we have a integration with LLM, but for implementing such kind of AI agent, we use LLM for get some kind of reason what user would like from us, what kind of request he has, and based on this request, we would like to understand the reason of the user. Once we have this kind of reason, we use our AI framework like Chain4j, Spring AI, or other to define what kind of action we need to do for this kind of reason, for this request from the user. And that's why we create our functions, we create the tools, and in scope of this tool, we can, for example, contact database, make another call to API, or all other things. For instance, for example, we are working with ordering application, and client via our agent confirmed the order. And based on this information, we would like to understand the reason of this kind of request. And based on this request from the user, we understand that we need to find the function or tool to update our table with the orders and make this order confirmed, act on this kind of reason from the user. Yes, this is very interesting, and I believe it should be also familiar to you. And last also, but not least, in my presentation, it's a multi-agent implementation or reflect pattern. Danila, could you please move on to the next slide? Yeah, I guess we have a... Yes, also a bit similar to the previous one, but if we are talking about multi-agent, usually after the request, we have some kind of agent orchestrator, which able to define based on request what kind of specific agent or specific set of agents should we contact to provide detailed answer, to provide good answer to our user. And as can you see again, after the agent orchestrator, we can talk to one or three agents. After that, we have some kind of summarization agent, and at the end, we have a resolver agent or critic agent. This is most important one. That's why we name this reflection pattern, because reflection means we would like to evaluate the output which we got from the previous step. And this last important step can give us some kind of information. Is it enough for completing the request and provide the answer to our user? And this is also very interesting one. And at the same time, such kind of implementation require additional knowledge. We have a lot of implementation step. We have a lot of change when we need to contact one LLM, get the response, after that summarize. And this is not a simplest pattern, but also very useful, and in scope of integration with our enterprise applications, it's usually very useful. Yeah, I guess that's it from my side. Maybe we have any questions.
Yes, we have, but we have to skip part of them. So I will ask you to address one. So maybe you can name 3 most common pitfalls or mistakes that you faced during your integration of AI.
Yeah, it's very good question. Actually, I can name them because it wasn't such kind of big pitfalls. It's not was some kind of big issue for us, but most important thing which we need definitely review and concentrate during the working with AI, it's first of all question regarding the cost. Calculate your tokens, try to create some kind of limits, because for each kind of request we pay the money, and we need to monitor all such kind of things. And also next, and very important, we need to usually to verify the answers from AI. And hallucination is most important issue during working with AI technologies, and that's why we need to create some kind of tests, verify what kind of answers we have. And this is also a very important thing during implementation such kind of application. And again, I didn't have any kind of big issues with working with AI, because maybe we just started working with them, but maybe we have already experience working with AI. But from my experience, this is most important two things which we need to consider.
Thank you. I believe that this information is useful for our viewers. So we have one more section. Let's give the floor to Artem about real use case, not some architecture.
Yeah, hi again. I hope you can hear me well. So I will tell you about one of the real use case, an application which uses AI, specifically large language models, heavily. And this solution is to basically generate unit tests, mass unit test generations. So we call it AI TestMate, tool which might help to increase test coverage for the project. So when this project started, we had like several goals, basically to first one, improve code coverage, especially it's relevant for like legacy projects, for projects with a lot of code and less coverage. And the second goal was to enhance development productivity, because basically people might have to spend less time for like writing and maintaining legacy parts of the code base, especially having no unit tests. So it should increase, it should basically reduce time spent on such areas, specifically regarding test cases, maintenance, and creation. So let's review the solution on high level. What we have, we basically have several components. First one is, we call it parser. It takes target code repository and parses it. So parsing involves many things, but if just put it in a few words, we extract various data from the project code base, like functions, classes, methods, try to build some mappings between methods and unit tests. And all this data is stored then in the database. So it can be also called an analysis of the repository. We also analyze coverage, which areas are not that good, which components might need the coverage increase, etc., etc. Then we have another component which actually does the main job. So first one is we generate test cases for methods we decide to target, and then we try to generate the code itself of those tests. We also build and run these tests. We check that they increase or do not increase the coverage, and save some results as a part of the post process. And at the end, we have some quality gates for results. For example, if the test does not pass, it obviously is not very useful. However, there are some complications. Let's say test can, for example, pass, but it cannot increase the coverage, or it increases the coverage, but maybe it's not that useful test. So there are some challenges, but overall, we can say that we have some processing of the results. And at the end, we get a bunch of tests in, let's say, diff format, if not going into much details. So we can maybe move to the next slide and review results. we got after some initial runs and tests with different repositories. So not so long ago, however, today maybe not quite long ago, Meta or ex-Facebook, they posted a white paper with some kind of research. They did a very, very similar thing on their code bases, specifically Instagram, if I recall correctly. So they, as a part of the some hackathon, implemented a very similar tool, and they got results which we can see on the left graph. So some tests were obviously built successfully, some not. Some were passed, some were rejected, and also some of them were adding some coverage. And as their results state, they have 25, let's say, % of all tests which bring some coverage to the project. For our results, we have tested it on various repositories, but we have slightly better results in terms of coverage, which was added. So, like, let's say, more or less half of our tests were adding coverage, not just passing. And overall, yeah, pass number of tests is also slightly bigger. So we can say that our results are better than ones from that research paper. I guess this is because our solution is just more complex. I didn't mention it earlier, but we not just ask LLM to write some tests. We also try to provide some relevant context, some examples, which we take obviously from the parsed repository, which is contained in our database. So maybe it's worth to mention some challenges. First, it's not so trivial to write a meaningful and good unit test. So for now, still manual code review is very recommended. I would say it's required, because sometimes test can bring coverage, it can pass, but it can be not so neat, not so perfect in terms of code style, in terms of some, let's say, mockings, some preparations. Also, LLM can sometimes try to do some hacks, just as some developers might do. And also one of the challenges is how to select tests which we are going to deliver as part of our results, because coverage is a useful metric, but it's obviously not enough to rely on it. So one of our improvements, we tried to also use code mutation, test mutation score. So we not only run our test, but we also run mutation tests with our test and see how much mutators are killed. And also we try to just do another LLM call and ask LLM about code quality of these tests. And I cannot say that we have, let's say enough, just, I don't know, enough measures to have really good tests and to differentiate between good tests and not good. And I guess that's pretty much it about the solution. If you have any questions, I am
thank you
ready.
very much, Tom. So I would like to ask, so you briefly touched upon the technical specific of the solution. Could you please dive into details if it's not forbidden?
Yeah, so actually we don't use Java as a primary language. We wrote our solution on Python, but it does not matter much, because we didn't use any specific frameworks which are available only for Python. For LLM communications, we use plain HTTP requests and responses, and we do all the necessary parsing ourselves. So in this case, the same solution could be written on Java easily. We use Java platform, JVM, and .NET platform for language tooling in order to compile the code, in order to run some tests, in order to run coverage, etc., etc. We also use length views for tracing and observability for our prompts, for responses from LLM. It's very useful. length fuse, not length chain. So it's two completely different things. And yeah, so basically that's pretty much it. We don't use any further like frameworks or specific libraries, which is worth to mention, I would say. We also use Elastic as a database. Yeah, that's pretty much it.
Artem, we also have a question from the chat. What is the size of repositories which you used during this?
Well, yeah, actually we used this tool on various repositories. Some of them were maybe several tens of thousands of lines of code, and some of them were several millions lines of code. However, it was to mention that we do not cover like everything, every repository, all code which is not covered in unit tests. So we delivered some amount of unit tests. Yeah.
Yeah. Yeah, thank you. Also, I see the question regarding the count the tokens. I see the answer as well. Regarding the Java library, which provide such kind of capability, actually, currently, I am not on this kind of topic. I didn't touch this count tokens last time, but initially when we implemented our solution, actually we implemented our own tokenization library, which we still currently use as I know. Maybe I already switched to a new one, but if I will be able to find these libraries which can help you, I definitely share with you.
Also, my 2 cents here. The length fuse, which I mentioned we use for tracing, it also supports seeing tokens amount, all different aggregations, and it also supports some kind of heuristic to have approximate number of dollars spent for different models. So it can differentiate between GPT and like Gemini and other models. So it's also very useful in terms of counting the tokens and costs for the project. Yeah.
Okay, and let's move on then. We run out of time. I wanted also to highlight several words regarding our AMGC school. If you don't know, please feel free join via the link. This community allows you to teach, to learn. At the same time, if you have a mentor capabilities to mentor and teach some students around the world Java, we have a lot of different education materials. We organize and create also events, and feel free to join the MGC community as well. Yes, and actually, I believe that's all for today, what we have. I believe Nastya already provided the link to the VIA community. Colleagues, please evaluate the talk. If you are able to provide the badge to the speakers, it will be very useful for speakers and for community as well. Say thank you if you agree and if you like this event, and also if you have again, if we didn't touch some kind of question, we will review it offline. If you would like to discuss something else offline, feel free to contact us directly as well. Yeah, Vova.
I believe that's it. Maybe I would like to add only to ask you to subscribe this channel, because we'll have more engaging and valuable meetings for you, and that's mostly it.
Yeah, if you would like to I don't know, to talk about some kind of details in AI, if you would like to learn some additional pattern of implementation, also please write down to the comments and we will try to organize something else and try to explain more about this specific of implementation, because this is, I believe it's very useful and interesting for all of us. Thank you for joining.
And I believe that we would like to share also results
Yeah, results of the poll. Yes, thank you for your answers as well. As can you see, customer support most useful area where we have a benefits to our client. Summarizing the meeting, very interesting. Education as well, marketing, super.
As you can see, we have 5 answers from 4 people. So
Yeah.
maybe customer support was right by the one, by the same
maybe.
one.
Next one. Your favorite LLM model, I guess, ChatGPT. But as can you see, we also have a Mistral with different kind of parameters. It's great that you touch small LLMs as well. And last one, yes, simple integration via API, which what we have currently, but I believe we will evaluate as well, and we will transfer our application as well to multi-agent, for example. But again, all such kind of patterns depend on the business needs. And if you have such kind of business needs, feel free to use it. Again, thank you for attending this session and see you next time. Thank you. Thank you all of us. Bye-bye.